Today we'll have an overview of the merge sort algorithm, which is recursive. And given an array of numbers that need to be sorted, see here we have the number of elements being 8. This array gets recursively broken up into arrays that are half the length. And that keeps going on until we reach a stopping condition where we have separate arrays with one element in them. And then next comes the merge operation. And to analyze the merge operation, we'll start with a couple of examples to see how it works and determine the worst case. So given two already sorted lists, the merge operation starts by comparing the first elements, and 1 is less than 5, so 1 gets placed in the merged array. And the iterator shifts to the right in the first array. And then 2 gets compared with 5, and 2 is less than 5, so 2 gets placed in the merged array, and the iterator shifts to the right. And then 3 gets compared with 5, and 3 gets placed in the merged array. And again the iterator shifts to the right, and then 4 gets compared with 5, and 4 is less than 5, so that gets placed in the merged array, and we run out of elements in the first array to compare. And therefore the next step in the merge algorithm is to place the remaining elements in the merged array. So where all the numbers in the first array are smaller than those in the second array, we required 4 comparisons. Now consider this case where we have 1, 3, 5, 7 and 2, 4, 6, 8 in the two sorted arrays. So again we compare the first elements, and 1 is less than 2, so it gets placed in the merged array, and the iterator shifts to the right, and then 3 gets compared with 2, and 2 is less than 3, so 2 gets placed in the merged array, and the iterator shifts to the right in the second array. And now 3 gets compared with 4, so 3 is less than 4, and therefore the iterator shifts in the left array. And then 5 gets compared with 4, 4 is less than 5, and therefore the iterator shifts in the right array. And 5 gets compared with 6, 5 is less than 6, so the iterator shifts to the final element. And then 7 gets compared with 6, and 6 is less than 7, so the iterator shifts to the right. And then 7 gets compared with 8, 7 is less than 8, and there's no more elements left to compare, so therefore the 8 gets placed in the array. So in this second case, we required 7 comparisons. And this here is the worst case. So in general, to merge two lists with n elements, so in this case we have n equals 4, we required at least n comparisons, and at most 7 comparisons, so that will be 2 by n minus 1 comparisons. And now we go back to our merge sort algorithm, being a divide and conquer or divide and merge algorithm. So we've completed the divide stage, where the array gets broken up into subarrays recursively. And then we get to the merge part of the algorithm. So here we get each of the 2 arrays being merged. So we get 1, 5, 3, 7, and so on. So what we got is 4 merges, which is 2 squared, multiplied by 1 comparison, required for each merge. So noting our merge algorithm here. And then these subarrays get merged. So what we get is 1, 3, 5, 7, and 2, 4, 6, 8. And this is done using the merge algorithm which we just covered. So as we saw in the worst case, we required 2n minus 1 comparisons. So here we had 2 merge operations and 2n minus 1 comparisons. So that would be 3 comparisons for each. Given the length of each subarray is 2, so 2 by 2 minus 1 in the worst case. And then finally, we merge these 2 arrays in the final array. So we get 1, 2, 3, 4, 5, 6, 7, 8. So what we got is 1 merge, which is 2 to the 0, and the number of comparisons is 2n minus 1. So 2 by 4 is 8, minus 1 is 7 comparisons. So you can probably see that this algorithm is a lot more efficient than the selection sort and insertion sort algorithms, which involve nested loops. So the code's a bit complicated and outside the scope of this course, but comment below if you're interested in the code, and I'll cover it in another video.